welcome to my YouTube channel Atmotech, and my name is Sonal Singh. So let's start our today lecture, which is based on the DFS, that is the full form of DFS is depth first search. And now we will discuss about overall theme of what is basically a DFS and what is the recursive and the traversal format of this one by writing a code in this also. So before starting further, I suggest you that please watch my all videos that I created in the past so that you can clear all the basic concepts of all the notes that I provided you, so that no problem can be faced by you. So I open this one because for the notes reference, and now we will discuss about what is basically depth first search, and this is also sometimes called depth first traversal, and is it a recursive algorithm for searching all the vertices of a graph or tree data structures. Traversal means visiting all the nodes of a graph, means that in simply way you need to search out that all the vertices of a graphs by going moving with edges and using every nodes to search all the by default values to get the desired output by simply use to search a search function. So in standard DFS implementation, we put each vertex of the graph into one of two categories, that is visited and non-visited. So it can be seen that we can simply divided the whole algorithm into two parts, that one thing is visited and second thing is not visited. So it is simply shortened our code visibility and extensibility so that it can be easily run in our terminal and for most effective way, because its time complexity is constant, or and also as its space complexity is also very good because it needs very less variables in it, so that the size of whole code is overall shorter, and we only simply divide it into two parts, that is visited and non-visited, which is basically depend up to the user that what kind of data it need to be retrieved and what kind of data it not to be retrieved. So it is overall the value of visitors question to ask about everything that is required for the purpose, and the purpose of the algorithm is to mark each vertex as visited while avoiding cycles, so that it can be simply written that it does not count the repeated function of the visited node, because it can uniquely be counted the visited node. When we also see out the application part of this, that the redundancy pattern of photos in the Google Photos like also, so it can easily be available for getting the result, desired output, that first thing we get our photo and not we it reach to the other one also. So it is very helpful in slides also, because it can visited only one and only unique. So we move further forward by knowing about what is the basically function of DFS algorithm. So start by putting any one of the graph's vertices on the top of the stack, and take the top item of the stack and add it to the visitor list. Create a list of that vertex adjacent nodes. Add the ones which are not in the visitor list to the top of the stack. Keep repeating steps 2 or 3 until the stack is empty. So it can be easily understandable that when we search out every node line by line, so it can be everything is empty. So empty in sense it shows that we move every node each by line, and also we use edges of these three nodes. And now it's time to visit about the DFS pseudocode. So in this we read about what is the pseudocode of this DFS, and sometimes we called it as recursive implementation. So recursive in sense that we used to go every node line by line, and by taking the terminologies of these words, that is simply search, and by using the visited and non-visited. So these overall are the terminologies of certain types of data structures. So not be confused about that, but you only concerned that how is the time and space complexity affect by the using these terminologies. It is the basic effect of these stack data structures, and also many things that is helpful and understandable, that is the pseudocode for DFS is shown below, that is in this way. So in this we use the init function. Notice that we run the DFS function on every node. So it's most important to understand that we use every node functions, not only single one. So we used to visit each and every node, otherwise it is shown not visited, and it is not useful in our code implementation and execution of our actual code product. And now in this way we use this is because the graph might have two different disconnected parts. So to make sure that we cover every vertex, we can also run the DFS algorithm on every node. So it is the most important part of this one to understand the whole code of DFS, that is we need to go through each and every node and to collect each and every vertexes, because for getting every vertexes it can be easily implemented to run our code and understandable by our compiler to adjust our each and every node terminals. So in this way we used to understand more accurately. So we start our writing in our VS Code editor to implement the code in DFS algorithm. So guys, let's understand the whole code of DFS that we implemented in the graph, and these all are the graph terminologies. So not be confused anymore, because graph is not a short term and conditions for anyone, because graph is a whole non-linear data structure, so it needs time to invest in them, and also we need to learn each and every terminologies of graph data structure to understand more accurately. So in this way we simply create a class graph, and we used to use integer private vertices that we use in our personal use. So in this way we use linked list integer, and these are currently used one by one because these are the basics of Java DSA and Java also, and other one also. But in Java this is used in linked list format, and it is very important to visited all the previous lectures of my YouTube channel. So please guys stay tuned with my YouTube channel, subscribe it and like it with and share with your friends to get more connectivity with me. And now we use public class, and we use public graph integer vertices, and we use this function to simplify the vertices, that this vertices is only vertices, and we use adjacency list. In this way we all studied about what is basically adjacency list, which is the basic terminologies of graphs, and also it is available in adjacency matrix, and we also implement the code of adjacency matrix in our future videos. And now we study about what is the total format. In this way we use for command in this for loop, and we give a suggestion of this one, that adjacency list and giving the integer value I is always equals to new linked list, and this is the actual format of linked list notations. And now it's time to use public word add adds integer source integer destination, and this way we use add adjacency source dot add destination. So you can also be seen that it is also useful in graphs and also useful in maps, that is we use to destination, and also these terminologies are basically mm, very similar to the maps that is also seen in Google Maps and many other sources like etc etc. And we use other one also, that is a start vertex, and we use boolean format in this way. And now we again use private word DFS util integer vertex boolean visited, and we use visited vertex is equals to true, and we now print the value of vertices in this way. And we again use for command for loop in this, and also justify a statement of if, because this is the condition for this one, this overall code. And now we use DFS util never visited, and this is our main Java boilerplate, that is public static void main string args, and we use a graph, and this is the notation of graph, and we use new graph, and then we justify the actual number of vertices in our overall graph data structures, and we used to DFS algorithm in it. And now we add edges like source is equals to 0 and destination is 1. And other way we use this one because this I read this one that this is the node and this is the branches of this one. So it can be simply in this way, that is this one, and now this is this one like this, and now this is the one that is connected with 0 and other 0, that is this one. And now we use to retrieve from this value to this value, and this destination is equals to 3, and we use second one, that is destination second is, and also we use 4 in this way. So this is basically a non-linear data type structures. And we use system.out.println for retrieving the actual output of our VS Code editor terminal box. And now we use to simply use the graph.dfs start vertices from second. And you seen that this is the one part and this is the second part for retrieving the value of this one. And now it's time to run our code in our Java terminal box. So let's see what's occurred in this. So this shows the vertices are 1, 2 and 3, and edges are 1 goes to 2 and 2 goes to 1 and 3 and 3 goes to 2. And DFS is starting from vertices 1, that is 1, 2 and 3. So this is the overall code of DFS algorithm. So I wish that you all understand each and every clear point of this DFS algorithm. And I know that you are very exciting for our new lecture series. So, and I give also gave away for all of them, for who's one who supports me and show their love and also motivate me a lot. So I also gave a giveaway for all of you. So stay tuned with my YouTube channel, subscribe it, like it and share with your friends. Thank you guys. Love you all.